Hi guys. So we're back again today and we're talking about something called linear inequalities. So remember, linear has this word line in it. So we're going to be graphing things with two variables, which means a coordinate plane. We're going to be making lines y equals mx plus b, or we may end up with things like ax plus by equals c or whatever. So pause right now if you need to go print this out. If you don't have a printer, that's fine. Just make sure that you have some way to capture everything that is on this page. And I mean everything that's on this page. First thing you need to do is when you have a linear inequality, you have to notice that we don't really know how to graph this set of solutions. There's an infinite number of solutions, even more so than what's on a line. The first thing we're going to have to do is actually just change that symbol. That inequality symbol is going to be changed to an equal sign so that we can actually have something we know how to graph. So this is a line that's in y equals mx plus b. I'm going to just record down here. This is y equals x plus 2. That is a slope of 1 and a y-intercept of 2. And then when I go to graph that, I'll have that information down here. The second thing we have to recognize is that we're going to be making a boundary line. So analogous to what we were doing on the number line, when we would be drawing closed circles for including solutions that are on that closed circle, if I use a solid line, then that means that I'm including points that are on that line. If I use an open circle, then I am not including points that are on that line. So these are same kinds of things, except this one is the lines are for boundaries on two variable inequalities, whereas the circles are for single variable inequalities. This will start to make more sense in a minute. So since this inequality is a greater than symbol, that means I'm going to be using a dashed line. So down here now, it says identify the best way to graph. This is why we went through different graphing methods last class. Just a reminder, since I have a y-intercept of 2 and a slope of 1, I'm going to use that to count where my line's going to have to go. And I'm going to go ahead and make a dashed line that goes through those points. Next thing I have to do is, after I've graphed this, it says to test a point. Now the reason I have to test a point is you'll notice that this graph now is split into two sections. That line is a boundary. Either the points over here are going to work or the points over here are going to work in this inequality. So an easy thing to do would be to test a point, see if things over here work or see if things over here work. 0, 0 is clearly a point that I can identify, and it's obviously on one side of that half plane. So I'm going to test using that point because it's easy to use. What I mean by that is I'm going to use x as 0 and y as 0. So you'll notice over here, I'm checking. If x is 0 and if y is 0, do I end up with an inequality that comes out true or false? Well, if I substitute those in, I get a false statement. What that means is the points that are on the side with 0, 0 will not work in this inequality. And so I am going to shade the other side of this half plane. All of these points, this is what that means, all of these points over here will work in the inequality, and the ones that are below the line will not.